Hi people, and welcome to this video. In this video, we will be working on the Mathematics Paper 1 for May-June 2026. Okay, so for those who are rewriting, this is the paper that you wrote. The marks allocated to this paper is 150 and the time is 3 hours. I will be releasing these in sections, so this is going to be the algebra section of this paper. So by the time you're seeing this exam, okay, by the time you're seeing this video, all the other questions have already been uploaded. It's just that if you are a member to the channel, you will see it first. Okay, so channel members will see the video first. And lastly, applications for my online maths one-on-one lessons are still open. Okay, you can sign up on my website at mathtruly.com/tutoring. Okay, so with that being said, let's look at the instructions. So again, as usual, we need to make sure that we correct to 2 decimal places. And remember that the diagrams are not necessarily drawn to scale. Okay, so even if something looks like 90 degrees, if they don't tell you that it is 90 degrees, you cannot assume this. Okay, with that being said, let's get into this video and we are working on question 1. Okay, question 1.1.1, we need to solve for x in this equation. So do you see that we have an exponent of 2 there? So that means that this is a quadratic equation, okay? The highest exponent is 2. And so we need to factorize this. But you can see it's not a trinomial. However, this is a square value, x squared, and 9 is a square number. And then there's a minus in the middle. So we can see that you can factorize this using difference of 2 squares. So we open up 2 brackets, equate to 0, and then you're saying what times what gave you the x squared, or really just square root the x squared. And then you get x, okay? So it's x multiplied by x that gives us x squared. And then what is the square root of 9? That would be 3. So you just say it's a positive 3 and a negative 3, and that has been factorized. And then solve for x, okay? We're saying something times another thing gives you 0. The only way this is possible is if the first is equal to 0, and so you said 0 times the other one and gave you 0. Or if the second one was equal to 0. And so you said this times 0 and then it gave you 0. So therefore, we say x plus 3 is equal to 0. Therefore, when you take the 3 over, you're going to get negative 3. Or again here, x minus 3 is equal to 0. If you take this negative 3 over, you get a positive 3. And so these are our answers. Moving on to the next question. The next question, 1.1.2, we have been given another quadratic equation, but this time we need to solve for x correct to 2 decimal places. Okay, so this is going to be a quadratic equation with irrational solutions, not rational ones like these ones. So we have to use the quadratic formula. Remember that your equation is written in the form of ax squared plus bx plus c is equal to 0. So it's currently complete, and we can see the value of a, b, and c. So here is our quadratic equation. Okay, and then we say x is equal to negative, and we just have b as 3. So we'll say 3 plus minus the square root of 3 squared. I mean, you don't really need the brackets, but it's fine. And then 4a, and then a is 2, and c is negative 7. Okay, and then you put that all over 2a. So 2, and then multiply by a, which is 2. And let's go ahead and get our first answer. I'll start with the plus first. Okay, and our first solution is 1 point, and that gives us 2. Now you see the 5, it's going to round the 6 up to a 7, so 2, 7. Or x is equal to, and then I'll change that plus to a minus. And now we have negative 2 points. Okay, so you can see that that 5 is going to add a 1 to the 6, so that's going to be 7, 7. And these are our answers. Moving on to the next question. Okay, the next question, 1.1.3, for 4 marks, we have to solve for x in this quadratic inequality. Okay, so I can see that this is negative. And so something you can do is just decide to take everything over. Okay, and this would work out. Or we could still just get rid of the minus by dividing both hand sides by negative 1. So there's 2 ways you could go here. You could say negative x squared, then plus 3x, and then bring the negative 4 over to become a positive 4. Then this is greater than 0. And then you can say, okay, there's a negative here, and you can decide to divide or multiply both sides by negative 1 just to get rid of that negative here, and you can factorize, okay? And then that would just give you x squared minus 3x, and then minus 4 is less than 0. Okay, the sign will change when you multiply or divide by a negative value. Okay, so that's one way to do that. Another way to do this would be you could just decide to take all of these over so that they are now positive. So when you do that, what will be left on the left-hand side? That will be 0. And then you have 0, and then the sign is still greater than, okay? So greater than, and these come over to become positive x squared, and then negative 3x. And then remember, this is already on the right-hand side, so it stays negative 4. So do you see how we have the exact same thing here? Okay, it's just the way the inequality and the 0 looks right now. It's a little different. So you could still put this on this side and you have x squared minus 3x minus 4, and here's your 0. Now, when you look at this inequality, okay, when you look at this open part, this part here, right, do you see how it's facing the 0? You're going to have to draw it facing the 0 here as well. So it would look like this. And you see how we still get the same thing. So any way you use will still be fine. Okay, and that's really just a simple explanation for why we change the sign. Okay, so this is what we have, and now we can factorize this. So we open up two brackets, still less than 0, and we're going to look at the first term. So what times what gives you x squared? That will be x times x, and then what times what gives you negative 4, okay? But when added, will give you a negative 3. So factors of negative 4, 4 times 1 gives you 4, okay? So one of it needs to be negative, clearly, for us to get a negative 4. So you need to make one negative, but when you add these numbers together, they should give you a negative 3. Okay, so in this case, I will give that negative to the 4. Okay, that way I have negative 4 plus 1, which will definitely give me negative 3. Okay, so the bigger factor must take the negative in this case. So our factors are negative 4 and positive 1. Okay, so this is what we have. And now we can go ahead and find our critical values. So our critical values are just those points where your solutions will start, or they'll really just be a marker for where you start looking for your solutions, okay, your x values. So you find these by simply just saying, if you had this same thing and then you just said it was equal to 0 and not greater than 0, this is how we would find the critical values. And so if you had this situation, okay, and then you said it's equal to 0, you simply just say, okay, something times something gives me 0, therefore x is equal to 4. Okay, or x is equal to negative 1. We're just solving for x like we did in question 1.1.1. So we know our critical values are simply just 4, and we also have negative 1. So these are our critical values. Now we can finally solve for x. So to solve for x here, it's an inequality. So I'm going to go ahead and use the graph method because I feel like this method is more suitable for grade 12s since you guys deal with graphs a lot and having to, manipulate the graph or interpret what the graph is doing when you have like f of x is greater than 0 and things like that. So I would rather use the graph method with grade 12s and students rewriting. Okay, so here's how we work with this. Do you see at this point where it was still a quadratic expression that we had where we could clearly see that squared on the x? If you had to graph this, if you had to draw this on a graph, what kind of graph does it create? Well, it has x squared. The highest exponent on x is a 2. So this will be a quadratic function, which is a parabola. Okay, and so you can see your parabola here. Look at the value of a. It's in the form of a x squared plus bx. Okay, so that's our b value. And then plus c. So our value of a is an invisible one. It's a value that is greater than 0. And so if a is greater than 0, you know that your parabola is going to be a concave up parabola, okay, or smiley face. So we know what our parabola looks like, and we can put down an x-axis so that we can put down our critical values. So our critical values are 4 and negative 1. The 4 will go on this side because it's the bigger value, and then the negative 1 is on this side. So we'll have -1 and then 4. And now let's go ahead and answer the question. So the inequality is specifically saying that x squared minus 3x minus 4 is less than 0. Okay, so when you substitute x values in here, it should give you an output or a y value that is less than 0. That's really what it's saying. So let's look at this graph. And where are our y values? Our y values lie on the y-axis. Okay, and you know that with the y-axis, you have two parts of it. There's this part where if you look at all these numbers that are here, okay, These are numbers that are greater than 0. These are numbers that are positive, okay? And then if you look at the numbers here, these are numbers that are less than 0, numbers that are negative. So which one does the inequality ask us to look for? The inequality says less than 0. So you're going to look for the parts that lie here. Okay, so all the y values that are negative. So if you look at your graph and we're looking for where do we have negative y values, you can see that they're over here. You're going to look at the graph and map where it's going to always have negative y values. Look at these parts, okay? These, they all are made up of points. They're little points here. Look at this point's y value. It is a positive y value. That's not what we're looking for. We're looking for negative y values. So look at this point's y value. It has a negative y value, and that's what we want. So we're going to highlight all the parts of the graph that have negative y values, and you would notice that those would be the parts of the graph that lie below the x-axis, this line. Everything below here has a negative y value. You can go ahead and take those points and map it to the y-axis, and you see that they're all negative. Okay, so now that we know this is where our solution lies, okay, this is the part of the graph they want us to focus on, what we need to do next is tell them the values of x for which these parts exist, because the question is to solve for x. So what are the x values that belong to these highlighted sections of the graph? You can find these by simply just lining this to the x-axis to understand what exactly these x values are. So do you see? All of these are little points, okay? And look at their x values. Their x values are all these values in between here. So all the values that lie in between -1 and 4, all of these values. And so we can express them like this. We can simply say, I'll put it in interval notation first. I can say x is an element of, and I can say these are all values that are going from -1 all the way to 4. And so I'll write it as -1 to 4. Now with the brackets, you see that they simply just said less than 0. They didn't say less than or equal to 0. If they said less than or equal to 0, then you would also have to consider the x values that make this expression equal to 0. Okay, those x values would specifically be 4 and -1. Okay, if you take 4 and you put it into this equation as an x value, you'll get 0. Okay, and if you take -1, you will also get 0. But they didn't say less than or equal to 0. They simply just said less than 0. So in this case, we cannot put a square bracket here because the square bracket would indicate that -1 is part of your solution, but it's not, okay? -1 would give you 0 when you put it in here. They don't want any value equal to 0. They only want values less than 0. So we use a round bracket here, and you see that we would also use a round bracket by 4 for the same reason. Okay, so that is one way to write your answer. You can also write it like this. You can simply write it in set builder notation, which would look like this. You'd say x is going from -1 to 4. So we say is greater than -1, but less than 4. And that would be our answer. Okay, moving on to the next question. The next question, 1.1.4, we are given an equation with a surd. Okay, so with equations with surds, you see that this is the surd. What we're going to do is try to isolate the surd. So leave the surd alone on one hand side. And so we will say the square root of, and we have 7x plus 2 is equal to, and I'm going to take the 2x over. But when I take it over, I want to write the 2x first, just because it's easier to square it like that. And I'll rewrite this as -2x now. And then we still have a +8 on this side, so +8. Okay, now that you've isolated the surd, we can finally get rid of the problem. The problem is there's a square root here right now, and we're trying to get to the x. So this is stopping us from getting to the x. And so to get rid of it, you would do the opposite of square rooting, which is to square. So you'd square this, but this is an equation, so what you do on one side, you must do on the other side. Therefore, now this cancels, okay, breaks open, and you have 7x plus 2 is equal to, and now we need to square this. So you can use this approach where you go -2x plus 8 times -2x plus 8, because this is what it means. It's saying this squared. If you had x squared, it means x times x. In the same way, it's this times the same thing, okay? And so you can use this approach, but I see that it does take longer, and so I use this quicker method. I take the first term and I square it. When you square -2, it becomes 4. When you square x, it becomes x squared. Then take the last term and square it. 8 squared is 64. And then you take the first term, negative 2x, multiply by the second term, and you're going to just multiply all of this by 2. Okay, so first term times second term already gives you negative 16x. And then times 2 gives us negative 32x. Okay, so this is what we have. Okay, and now we need to solve for x. So do you see that this is clearly a quadratic because we have x squared? And since this is already positive, okay, the coefficient of x squared is already positive on this hand side, I will just go ahead and take all of these over to the right hand side. So 0 is equal to, and we have 4x squared, and then you have a negative 32x, and then the 7x comes over to become negative 7x. Do you see how together they give you negative 39x? And then we have, okay, this is a plus, so a positive 64, and then the 2 comes over, minus 2, which gives you positive 62. Okay, do you see any common factor all through? That's a 4, that's a 39, that's a 2. No, okay, because here maybe common factor 3, but then, it's not common all through here. Because here you can see that 39, okay, 3 can go into 39, but, it can't go into 4 or 62. So this is something that we actually just have to take like this and then factorize it. Okay, now I know that the numbers are quite big, and so it can be intimidating to factorize. So you can just use this method. So we're going to use the quadratic formula here, but then we're just not going to show them because you will probably get marks for factorizing. It's probably just going to be like 1 mark, okay? But yeah, you're probably going to get a mark for factorizing. And so just look at this in the form of ax squared and then plus bx and then plus c. Okay, so we can see what a, b, and c are. So in place of b, I'm going to substitute the negative 39 because that's our b value there. And then b squared, so negative 39 all squared, minus 4, and then a, okay, our a value here is 4, and then our c value is a 62, so 62 all over 2a, but our a is 4. Okay, so here's how this works. What this is going to give you is the solution, okay, the x value that we have here. So x is equal to 2. That's what it's saying. I'll just put it this side, okay? Now, when you write it as a factor, you're going to think about it like this. You have the x, and then you take the 2 over. Okay, it becomes a minus 2. Because you must have had x minus 2, and then something here is equal to 0, so that you can say this is equal to 0, or this is equal to 0. And so you said x minus 2 is equal to 0, x is equal to 2. Okay, so that's exactly what we're going to do here. And we're just going to take that 2 over. So the factor that we had was x minus 2. Okay, and then you got a solution of 2. Okay, and then to get your second factor, just change that minus to a plus. There we go, okay? So it's going to be, you need to make sure it is written as a fraction. So it means your answer here is 31 over 4. And so what this means is to get this 31 over 4, just take this 4 and multiply it back to the x. And so what you had before was a 4x is equal to 31. Then take the 31 over and you have minus 31. And there we go. That's your factor. Because if you said this is equal to 0, you see how you would say 4x is equal to 31. Then divide both hand sides by 4 to get that. Okay. So it's just going to be 4x minus 31. That is your factor. And there you have your solutions and your factor, and you won't miss a mark there. Okay. I just use that method for, those ones that you have to think a little bit, just so that you can save time. But for the simple ones, just factorize it. That's fine. Okay, so we're not really done yet because we can't just say, oh, these are our answers. Remember that with surds, you still need to check if the answers are valid for this equation. Okay, so what I mean by checking if they're valid is you are checking if you take, because we're trying to solve for x. This is an equation, meaning the left-hand side must always just be equal to the right-hand side for the equation to be true, okay? For that x value to be valid for that equation. So what I mean by check is you're going to substitute each x value. You're going to take this. You're trying to find out, is x really equal to 31 over 4? And you will substitute it in place of x and check if the left-hand side is really equal to the right-hand side. Okay, if the left is equal to the right, then that means that answer is valid for this equation. Okay, it's true for that equation. So let's go ahead and do that. I'm going to rewrite this first. Okay, and then in place of x, we're going to substitute 31 over 4. And here again, 31 over 4. Now you can go ahead and put that on your calculator and check, does it give you an 8? Okay, so this is what I get. I get a 23, and I know that 23 is not 8, okay? 23 and 8 are not equal, and so I know that x is actually not equal to 31 over 4. Now let's go ahead and try the 2. And when I try 2, I get 8. Okay, so 8 really is equal to 8. That is true. And so this is our answer. X is equal to 2. X is not equal to 31 over 4. And that is our answer. Moving on to the next question. Okay, we are now on question 1.2. And we have solved simultaneously for x and y. Okay, so do you see the type of equations they're giving you? This one is, we're used to seeing something like that. But then they give you an exponential equation. Whenever you see an exponential equation or a logarithmic equation, don't get afraid, because the thing about these equations is you can still get a linear equation from them. Okay, simple example would be something like if I had 2 to the power of k is equal to 4. Okay, I know it's exponential, but there's a linear equation in here. If I decided, okay, this is an exponential equation, and so I need to make the bases the same, so I'll make this 4, 2 squared, then do you see how, since the bases are the same, you would make the exponents equal, okay? Because for the left to be equal to the right, these two must be equal. Okay, so we just say k is equal to 2, which is a linear equation. And so do not get afraid if you see an exponential or even a logarithmic equation, because those ones can still be turned into an exponential equation, and then you can get a linear equation from that. Okay, so let's look at this. We have 2 to the power of x and 2 to the power of y. Do you see that we have the same bases that are being multiplied? When the bases are the same and you are multiplying, then you need to add the exponents. So this is part of your laws of exponents. So this is 2 to the power of x plus y that we have there. But then we have a 4 in the denominator. I know that 4 can be expressed as 2 to the power of 2. This way I'll be able to divide these two numbers. Okay, and then all of that is equal to 1. And then I have 2 to the power of, now you have 2 to the power of an exponent divided by 2 to the power of another exponent. So to divide, if the bases are the same and you're dividing, you would subtract the exponents. So what you have here is x plus y, then minus 2 is equal to. Now you can see at this point that we have a 2 to the power of a value, okay, which has variables in it. And then you have a 1. So at this point, we can now make the bases the same. How can we rewrite 1 as a base of 2? You can rewrite that as 2 to the power of 0. Okay, so there we are. And here's your linear equation now. We have x plus y minus 2 is equal to 0. Okay, I'm just going to go ahead and form equation 1 with this. And so I'll make something the subject. Let me choose x. So x is equal to, and then I'm going to take these over. So the 2 goes over, the negative 2 becomes positive, and then the y becomes negative y. Okay, and I'll call this equation number 1. And then this is equation number 2. And now we can go ahead and substitute equation 1 into equation 2. Okay, so we have negative, or I'll just rewrite it first. Okay, so this is our equation number 2. Okay, so wherever you see x, we're just going to replace this with 2 minus y. Okay, so I have negative 2, and then there's x, that's 2 minus y, all squared. And then I have plus 3, and then there's x, but then there's a y here. So why don't you just put the y here, and then the x is here. So it's like changing it to yx. That way, we can just put the x here, which we know is 2 minus y. So 2 minus y is equal to, and then that's just y, so y squared. Okay, and now we need to solve for y in this equation. So let's go ahead and just distribute. We have negative 2, and then this is squared. Again, you can write it twice and FOIL out, but I'm just going to deal with this the quick method. So I take the first term and I square it, and I get 4. And then last term, the negative y all squared, that gives you positive y squared. Then the first term times the second term, that will give us a negative 2y. And then you just times this by 2, which gives us negative 4y. Okay, and then we can distribute here. So the 3y times the 2 is positive 6y. Then the 3y times the negative y, that is negative 3y squared. Okay, and then I'm just going to bring this over, it's fine. So that becomes minus y squared is equal to 0. Okay, let's distribute. So when we multiply in, we get negative 8, okay? And then the negative 2 times the negative 4y, that is positive 8y. And then we have negative 2y squared. And then we have the positive 6y. And these together, okay, negative 3 minus 1 gives you negative 4. So that's negative 4y squared is equal to 0. Okay, like terms together. So we have these two, they're like, we put them together. We have negative 6y squared now. And then we still have this and that. Okay, those two are like terms. So they will become positive 14y. And then lastly, this is just the only constant. So minus 8 is equal to 0. Okay, and then do you see that all through all of these numbers, they can be divided by 2. Okay, negative 2 specifically, because I want this to be positive so we can factorize. So we can just divide both hand sides of the equation by negative 2 and we get this. So this is going to be positive 3y squared, negative 7y, and then positive 4 is equal to 0. And now we can factorize. Okay, so to factorize this, you can see that this is the case where you already have a coefficient that is not 1. Okay, so I'm going to use the cross method here just because I feel like it's quicker. So we take the first term and we find out what the factors of the first term are. So 3y times y, that's what gives you 3y squared. And then we need the factors of 4. Okay, so that would be, let's say 4 and 1, or you can also just say 2 and 2. But let's try 4 and 1 first. Okay, now do you see that only the middle is negative? If only the middle is negative, you're going to make sure that this is negative and then negative. Okay, so the reason why they'll both be negative is because when you look at this, you say, okay, there's a positive 4 here. So what times what gives me positive 4? Okay, that would be, you could take a positive times a positive number and then it gives you that positive. Or it could be a negative times a negative number and it gives you a positive. But it's clearly going to be this case, because if it was this case, then how is this negative? Okay, so we know that these are both going to be negative. And now let's go ahead and check if it really does give us our middle term. So we're going to cross multiply. You say the 3y times the negative 1 gives you negative 3y. Then the y times the negative 4 gives you negative 4y. And this is equal to negative 7y. Okay, so with negative 7y, it really does work out to be the middle term. And so these are our factors. It's the 3y minus 4 and the y minus 1 is equal to 0, and we have factorized, and now we can solve for y. So you're saying something times something gives you 0, and so it means that either the first is equal to 0 or the second is equal to 0. So here 3y is equal to 4. I take that over, divide both hand sides by 3, and then y is equal to 4 over 3. Or here y would simply be equal to 1. Okay, and now we have solved for y and we need to solve for x. So just look through and see, did you have an equation that said x is equal to? Yes, we did. Okay, it was this equation over here. So I'll just say x is equal to 2 minus y. So here x is equal to 2 minus y, and y, the first y value we have is 4 over 3. And then you can say, or x is equal to 2 minus your second y value, which is a 1. Okay, so x is equal to, so I can express this as 6 over 3. Okay, so 6 over 3 still gives me 2. I'm trying to make the denominators the same. Then minus 4 over 3. So that gives us 2 over 3. So x is equal to 2 over 3. And then here, x is equal to 2 minus 1 is simply just 1. And these are our answers. Okay, so x is equal to 2 over 3 and y equals 4 over 3, or x equals 1 and y equals 1. Moving on to the next question. Okay, and we're on the last question for question 1, which says, given, and this is what we have. So given, do you see that this is square root 6p, but then we also have square root 6p here, and then plus, and then this is minus, and then the fourth root of 128 and fourth root 128. So can you see that they are using the difference of two squares? This is the factorized form of an expression which you would use difference of two squares to factorize. So if you were given something like x squared minus 4, you see that this would be, if you factorize it, it's going to be x minus 2 and x plus 2. Okay, so that's exactly what they did here. We can see the same value here, same value. Okay, also the same value here, same, but then there's just a plus and a minus. Okay, so we know how to simplify that. And they say all of that is equal to 54 plus a square root 2. And we need to calculate the value of a minus p. Okay, so we can just work with simplifying that first. We know that when you finally distribute, okay, it's just going to give you this. So you're just going to take the first term because you know that at the end of the day, those middle terms would cancel. Okay, so you saw with the x squared minus 4. So to get back to the original expression, you're just going to say this times this, or you really just square it. So if you had the square root of 6p and you square that, that would just give you 6p. Okay, so we just have 6p here. Then in the middle, you have a minus. And then take the fourth root of 128 and you're going to square this. If you square the fourth root of 128, a 2 would cancel here. Let me explain this in a slower way. So you see with the 128, I mean, you could, if you use your calculator, it's not really going to help you here because it will just simplify it. So with the 128, okay, the fourth root of this, if you had to rewrite this so that it's no longer a surd, okay, so that you have a rational exponent, you would rewrite it like this. You say the 128, then you take the inside exponent, okay? The inside exponent of 128 is an invisible 1, okay, because it's just 128. And then you'd raise it to the power of 1, and then you'd say inside exponent over the outside exponent. So this is just this right now. Now I'm saying this, I square this. And so what would happen here is you have a 128 raised to the power of, when you square, okay, that exponent is going to multiply to this exponent. You're saying 1 over 4 times 2, which gives us 2 over 4, which is really just a half. And so if you put this back as a surd, you are just saying we have 128. The inside exponent is a 1, okay, it's an invisible 1. The outside exponent is a 2. Since this is a square root, it's just going to be square root 128. Okay, so that's what we have there. And so we just have minus square root 128, which we can, of course, find the value of. Okay, so we can find the square root of 128. So this is equal to, and then we have 54 plus a square root 2. And then if we find the square root of 128, that gives us 8 square root 2. So we just have this is just equal to, so we have 6p minus 8 square root 2, and then it's equal to 54 plus a square root 2. Okay, and we're trying to solve for a and p, and then of course find the value of a minus p. Okay, so let's look at this logically. If they're saying that 6p minus 8 root 2 is equal to, okay, and I already see a pattern, square root 2, square root 2. And then it's a value in front and a value in front. Okay, so what they really just mean is this and this, they are equal. So we can look at it like this. If these two things are equal, okay, then what this means is, and I don't know why I still left the bracket here. It doesn't really need a bracket anymore. So this is fine. Okay, so what this just means is you have a value, okay, minus another value with a root, okay, with a square root 2 next to it. You can clearly see that that would mean that these two, they're probably the same thing. But then the only problem with that would be this is a minus here, and this is a plus. Well, the thing is you can rewrite this expression like this. You can call this 6p, and then you could still say plus negative 8 square root 2, and it would still mean the exact same thing. And so it's equal to 54 plus a square root 2. Now do you see that in what we have in this equation, okay, that the left-hand side and right-hand side are actually exactly the same. The 6p is the 54. And then the plus, and then the negative square root 2 and the a square root 2. Those are the same thing. And so can you see that now we can see that a is actually equal to 8, negative 8, okay? And then, of course, 6p is equal to 54. So that's what we have, okay? Because this is an equation and the left-hand side must be equal to the right-hand side. Then this means that 6p is actually equal to 54 and negative 8 square root 2 is actually equal to a square root 2. Okay, and then you can just solve for p and a here and find what they asked us to find. So to solve for p here, we'll divide both hand sides of the equation by 6. So 54 divided by 6, that gives us 9. So p is actually equal to 9. And then a here, just get rid of the root 2. Okay, so you can actually just say divide both sides. It's not really necessary, but sure. Divide both sides by square root 2. And so you see that a would simply be equal to negative 8. Okay, so this is a, this is p, and then just find what they asked us to find, which is a minus p. Okay, so a minus p is therefore equal to, and then we know a is negative 8, and then minus p, which is 9, and then 8 minus 8 is negative 16, and then minus 1 is negative 17. So this is our answer. A minus p is simply equal to negative 17. And that is the last question for question 1, and that is the end of this video. And I will see you guys in the sequences and series section of this paper.